Hello and welcome back to the CSC 126 Graphics and Visual Computing. Okay, and in this lab session, so we will explore how to manipulate images by moving, rotating, and flipping them using OpenCV. Okay, so by the end of the session, you'll be able to apply translations to move an image, perform rotations using transformation matrices, and understand transposing, and of course, flipping as geometric operations. Okay, so let's begin with, okay, by importing um, our required libraries here. And we have the for OpenCV, for NumPy, and for PyPlot using the Matplotlib. Okay. Then we have our utility function here to display the image. Okay. And here also, well, just the same as our um, recent activities here. So this is just the same data that we or the data directory will be used. Okay. To start, we have translation here. So when translation simply shifts an image either left, right, or up or down. So let's say we have an image. So all of the contents of image will be moved to the left, to the right, or up and down. So it depends on how will you want to move all the pixels in this case. So we will use the wrap affine in this case. So to transform the image. Okay, so what we have here is CV2 dot wrap affine. So here is the target image. Then T here is just for to the transform metrics here. What will be your transform metrics function in this case? Or what will be your transform array in this case? And this will be the width and the height for the okay, this will be the width and the height of the image. Okay, so here okay, let's have an example here. So we have an image read here, and well, we image showed. Okay, we utilize the image show here. So this is the original image here, and what we have here is that we would like to shift the image on the using the quarter of the height and the width of this image. So we just have to get the quarter height of this image and the quarter width. So we just have to use this equation here to translate the image. So as you can see, it just we just move the image using the quarter width and quarter height. So right now, we just utilize the equation or the matrix here. We just utilize the 1 0 0 1 in this equation. Then we just have to use the the tx, which is represents the shift along the x-axis or the horizontal, and this one is for the vertical. Okay, so we transform or shift this image to the quarter height and the quarter width of this image. So once we targeted now the quarter height and the quarter width and the quarter height, so the transformation would be this one is the width and the height of the image. So we just need to use the shape function here. So image that shape, then we just get the height and the width because that will be the parameter of the of this function here. So so as you can see, we have CB2 that warp affine the target image, the transformation, and or the translation here, and the width and the height of the image. So right now this is the original and this is the translated. So meaning the whole image pixels here is being translated to the quarter width and height of the image. So that's why it is moved on this region of the image. So okay, so it retains the width and height because of this one, and this is the targeted um, translation of the image here. So right now, what does the translation looks like? So we have this one. So 256 and 170.75. Okay, so this is the translated image using the this equation here. So just put values in here. So in our case, we just use the quarter height and the quarter width. And right now, it is translated here. Okay, so this is the value for the quarter of what? This is the quarter or the TX is what we use here is the quarter width. Okay, so the width here is so the quarter for 1000. So it is 1000 plus. Okay, so that's why it is 256 and the quarter for somewhat I think let's say 700 here. So it is 170.75. Okay? So it is just an estimate for it's just an estimate for this one. So it is 1000 plus and this one is 700. So this is the quarter for that. So this is the targeted point that is 256 here, 256 then 170.75. So somewhere here. So this is the translation point. So all the image pixels here are moved to this point. Okay, translation in this quiz. So this will be the first point here, or the first pixel will be targeted here, and all the pixels will come along here because it is translated to this point. Okay, so that's how the the translation is all about. Okay, okay for rotations. Um, OpenCV provides get rotation matrix 2D to build a rotation matrix. And what else? What we have here is this is the rotation matrix here, M. And what else we need is just the angle here, angle of rotation. Though in the to rotate a certain image, we just need the center of the image and the rotation angle of rotation here and the scale. So in this case, the scale is just to retain or you want to retain the scale of this image. So just use 1. Okay. So right now, For example, so we just have this is just an image before, so this one, and we get the height and width using the image.shape, and well, just we just need the two values for the height and width. Then so we just splice it to the first and the second one, or the first and the second element. Then next is we create the rotation matrix here. So obviously the center of an image, the center of this image, it is the width, and width divided by 2 and height divided by 2. So that will be the center of the image. So in this sample, so the angle of rotation here is 90. Okay? And what else? And we retain the scale of the image. So we use 1 here. So to have to translate the image, so we use the affine, wrap affine in this case. So we have the targeted image, we have the angle of rotation here. So well, the required for the affine is just the target, or the target transformation of the image. So as you can see here, the target matrix here is the rotation of this image here. So the rotation matrix in this case. Then we'll use the width and height of the shape, the original shape of the image. So right now this is the rotated image. So we utilize two functions um, of the OpenCV here. We create first the matrix here. So here, then we use the affine, wrap affine to translate the image based on the rotation matrix. So this one is rotated 90 degrees with scale 1. So it retains the scale in this case. For this example, we have the same, what we have here is that we just update the scale to zero point 0.5. In this case, the scale is half of the original of the scale in this case. So this is the new scale of the image while it is rotated to 90 degrees. Using the transpose, so what we have here is, we're just utilizing the transpose function here. So well, it just rotated the image based on the width and height here. So it just transpose the values of well, the orientation of this the height and the width. So this will be the new height, and this will be the new width in this case. So this is the height and the width. Okay, and somehow it zooms in this case. All right, so next is, if we want to transpose the image back again, so well, it will become well, back to the original scale, of course. So now, if you want to, in this case, or the proper one for horizontal flip is 1. Okay, so in this case, what we have here is, okay, from the original image, let's say this is the original image. So if you want to horizontal flip this image, so just use the parameter 1 here. If you want to use it or update this image into a vertical flip, so just use -1. So let's say this is a vertical flip. So okay, this is a vertical flip in this case. So well, just try to play around on the transformations on using OpenCV, and you will um, just apply any transformations and well just uh, try and test so that well this functions here is very important regards to adding new datas in um, your data set. So if in case you have a low quantity of data, so if you like to flip the image, transpose, translate, it is another type of data. So if in case you have just one data example here, if you want um, more variations of data, so you will just use this transformation like this one. This is will be a new data because this one is translated to a certain point. For example, here. So this will be a new data. And again, if you want to rotate, so just use the a series of well, you use the rotation matrix, then use the um, translation wrap affine here, and it will target to the rotation matrix. So as you can see, we have this one. So this one will be another data since this one is being rotated. And of course, this one will be a new data because it is altered the scale of the image. And horizontal flip and vertical flip are also another type of data since it is being transformed or all the pixels before or the recent pixels here, the position are flipped to the other um, opposite side of this image here. So the opposite here is this one. So that's why it is vertical flip. So all pixels here will be flipped here or transformed or transposed in this case. Okay, so for now, so that's all for this session for the transformation in OpenCV. So you will just have to study most of other translations and transformations in this module. So, well, thank you for your time and thank you for listening.